RC and RL circuits, first order circuit, chapter 7. Objective of lecture. Explain the operation of an RC circuit in DC circuit. As the capacitor stores energy when voltage is first applied to the circuit or the voltage applied across the capacitor is increased during the circuit operation. As the capacitor releases energy when voltage is removed from the circuit or the voltage applied across the capacitor is decreased during the circuit operation. Explain the operation of a RL circuit and DC circuit. As the inductor stores energy when current begins to flow in the circuit or the current flowing through the inductor is increased during the circuit operation. As the inductor releases energy when current stops flowing in the circuit or the current flowing through inductor is decreased during circuit operation. Natural response. The behavior of the circuit with no external sources of excitation. There is stored energy in the capacitor or inductor at time is equals to 0. For t, 0 is the stored energy is released. Current flows through the circuit and voltages exist across components in the circuit as the stored energy is released. The stored energy will decay to 0 as time approaches infinite, at which point the currents and voltages in the circuit become 0. RC circuits. Suppose there is some charge. Suppose there is some charge on an capacitor at time t is equal to 0. This charge could have been stored because a voltage or current source have been in the circuit at t is less than 0, but was switched off at t equals 0. We can use the equations relating voltage and current to determine how the charge on the capacitor is removed as a function of time. The charge flows from one plate of the capacitor to the resistor R1 to the other plate to neutralize the charge on the opposite plate of the capacitor. Equation for RC circuit. RL circuits. Negative VL plus VR is equal to 0. IL is equal to IR. BL is equals to L DIL over dt. IR is equals to VR over R. Initial condition can be obtained by inserting a DC source to the circuit for a time much longer than t and then remove it at t is equal 0. Capacitor, open circuit voltage. Inductor, short circuit current. Time constant, the time required for the voltage across the capacitor or current in the inductor to decay by the factor of 1 or 36.8% of its initial value. Singularity function are discontinuous or have discontinuous derivatives, also known as switching function.